On page 31, our first one is an addition reaction. And it's just the same as the addition reactions that we've already talked about, except the conditions required are a little bit different. These ones don't happen as readily as our bromination. And so you might notice that the water is in the form of steam, so it needs to be high energy, and it's also in an acidified environment to form the alcohol. Now, what happens is, just like with our other addition reactions, I'm going to just rewrite the water that I've got here down in the way that it can add across the bonds. And that's like that. So what we can end up with happening is that that bond breaks, and the bond within the double bond there between our carbons also breaks, so that we end up with an alcohol. So if we look at this a bit more closely, say, what we're saying is that this bond here will break, and that bond there will break, and they will then form new bonds. Now, you might remember from our previous addition reactions, though, that if we're adding just bromine, Br2, then we'll only have one product. But in this case, it would be possible for us to get another isomer if we have our water orientated the other way. Okay, so that in that case, our product would be this. So are you all able to see on your formula sheets how you can go from an alkene to an alcohol? And we need steam and an acidified environment. Now, if you want to follow along with the reactions as we look at them, you can like cross them off or put a highlighter through them on the formula sheet just to remind yourself that we have looked at them. But I want you to be getting into the habit of looking at these formula sheets because there's been plenty of times when in a test or an exam the answer is very straightforward if you know how to interpret that chart. Okay, so it's an addition reaction because we're completely adding across the double bond. The next kind of method we're going to look at is reacting an alkyl halide. So let's have a look at that as our second method, and you'll do this on Monday. Do this reaction. Now, remember how we talked about our functional groups as a site of reactivity? Well, that is something that's really important that helps us work out what's going to happen with our reactions. Now, if you're looking in the booklet, it says here Rx. Now, Rx here means that this is a structural formula, and that halogen can be anywhere on that molecule. Doesn't matter where. If we react it with the sodium hydroxide, the halogen will be replaced on that same carbon by the hydroxyl group. All right, so if we looked at what I'm trying to explain to you in more specific terms, what that means is what is going to happen is that our hydroxide is going to come along here and replace the bromine. So the hydroxide will end up bonded to that carbon, and the bromine comes off as the bromide ion. So our product then it doesn't randomly just go on anywhere. It must go on to the place where the halogen was previously. Does that make sense? So, yeah, our functional group is our site of reactivity. That is where the reaction is likely to take place. And then our other product here is then just the salt. And there was a question in the exam recently that asked students to produce an alcohol, and they were told to use 2 steps, and they started with an alkene. So what do you think you would do if you had to make an alcohol in 2 steps? And start with an alkane and start with an alkene. Okay, so have a chat amongst yourselves and see if you can figure out what you're going to do.